Welcome. I'm Dr. Bob Mayo, and this is Chapter 2 of Intermediate Microeconomics, the Budget Constraint. A large part of micro, although by no means all of it, is understanding behavior in markets. To understand markets, we need to understand the behavior of both buyers and sellers. The study of buyers is called consumer theory. The study of sellers is called producer theory. This is the first of several chapters focusing on consumer theory. Now, why do buyers buy what they do? The first and simplest answer is because they like some things more than others. Consumers have preferences. Preferences are subjective. There's no right or wrong to them because preferences are opinions. Now, to understand consumer choices, we have to understand their preferences, but preferences by themselves are not sufficient. For example, I have a preference for buying 10 Ferraris and a jumbo jet, but that's not what I buy because I don't have enough money. Choices are constrained by my budget. The budget constraint tells us what choices are possible and what choices are not possible. Now, after we can mathematically define the set of choices that are within the budget constraint, that is the set of choices that compose the budget set, then we can turn to preferences to understand which of the possible choices the consumer will pick. Now, we're going to model the budget as consisting of money, but it doesn't have to be. You have a time budget as well. You can't do everything you want because you don't have enough time. So you have to make choices for the things that will fit within your time budget. You could have a budget of space. You only have so much space available to put things. But we're going to use a budget of money as our example because it's the simplest case. And I've got the laser pointer working. Okay. The money in our budget will be used to buy different things. We're going to start by assuming there are only two types of things to buy. Think of it as apples and oranges. There's nothing else you can spend your money on. Now, we start out with two products because it's the simplest case that's interesting. Just one product isn't terribly interesting. And also because it's easy to draw graphs to demonstrate these issues in 2 dimensions. Drawing in 3 dimensions, it's possible if you're a good artist, but it's difficult. And drawing a graph in 4 or 5 dimensions, not going to happen. So, a consumption bundle is one particular assortment of commodities that you buy or can buy. 3 apples and 1 orange is a consumption bundle. To make the analysis general, we'll call the first item commodity 1 and the second item commodity 2. X is the variable name that we give to the quantity of each that you buy, and the subscript indicates which commodity we're talking about. So if the commodity is 1 apple, if commodity 1 is apples, plural, and you buy 3 of them, then X sub 1 would equal 3. And the eraser. For 2 goods, the consumption bundle is written and that is a 1, and that is a comma. It's written like this. It's essentially it's a vector. And we denote the price of each commodity with the lowercase p, with, again, the subscript indicating which commodity we're referring to. This would be the price of commodity number 1. This is the general form for the budget constraint. Total spending on commodity 1 is the price of commodity 1 times the quantity of commodity 1. If item 1 is apples, the cost of apples in this bundle is P1 times the number of apples, X1. You do the same for each item in the bundle, up to Pn Xn, if there are n items. Add them all up, and that is the total cost of the bundle. So spending is the left-hand side. Your income is the right-hand side. We denote that with M. The less than or equal sign means that the total spending cannot exceed your income. Now, we assume here that people don't get any utility. Utility is very similar to, you can think of it in simple terms as happiness. People don't get any utility from money. They only care about the things money can buy. So here we're assuming that people will always spend all their money, because if you have some money and you don't spend it, you get nothing from it. Now, we define all of the consumption bundles that people can buy. Here are all of them as the set of bundles with some quantity of the first thing, that'll be X1, some quantity of the second thing, that'll be X2 if it was written, up to some quantity of Xn for the nth thing. It is this set such that, and that is what the vertical line means, such that each of the values for the quantity of items must be non-negative. You don't have -3 apples in your bundle. And adding up the spending on each item exactly equals your income. This means there's no money left unspent. Now, the budget set is all of the affordable bundles. The budget constraint is the upper boundary of the budget set, where all the income is spent. This is it graphically. The horizontal axis is the number of commodity 1, and the vertical axis is the number of commodity 2. Now notice the endpoints. Now, how many of item 2 could you buy if you bought 0 of item 1? Item 2 has a price of P2, so it would be your total income divided by P2. That's that point. If you had $100 and the price of item 2 is 20, and you spend all your money on item 2, then you could buy 5 of them. So you would be at the point 0, 5. And the same works for buying item 1. Now, this is handy to remember because the budget constraint is usually a straight line. So if you know any 2 points on it, like that one and that one, you can algebraically derive the entire line. Now, each point on the graph represents a consumption bundle. Some quantity of item 1, some quantity of item 2. The light blue point represents this many of item 1 and this many of item 2. But notice it's beyond the budget constraint, meaning it is not in the budget set. The budget set here is the set of all affordable bundles. Now, the dark blue point there is in the budget set, so it is affordable, but it leaves money on the table. This is because it is possible from this point to have more of both, to move up and to the right. You can have more of item 2 and more of item 1. So a consumer will never choose that point. In this very simple model, a consumer will always choose a consumption bundle that is on the budget constraint. These are the bundles that are affordable, but just barely affordable, because the consumer is spending all of their income. Now, as I said, the budget constraint here is a line. The slope of the line is determined by the ratio of the prices of the two commodities. That's the rate at which you can exchange one item for the other. If the prices are the same, then the line will slope down at 45 degrees. It's a slope of -1. If P1, the price of commodity 1, is $1, and the price of commodity 2, P2, is $2, then you would have to give up 2 of item 1 to get 1 more of item 2. Giving up 2 of item 1 to get 1 of item 2, and the slope would be more shallow. It would be equal to -1/2. Now, what does a budget constraint look like if there are 3 commodities? Well, it looks like this. It's a plane. The math is exactly the same. You just have this one term added. It's the price of commodity 1 times the quantity of commodity 1 plus the price of commodity 2 times the quantity of commodity 2 plus the price of item 3 times the quantity of item 3. And that must equal the income of the consumer. And the budget set, the set of all affordable consumption bundles, is this 3-dimensional volume. But we're going to stick with 2 dimensions. If you understand it in 2 dimensions, expanding it to an arbitrary number of dimensions makes the math a little bit more complicated, a little bit longer, but the principles are the same. And it's easy to draw a budget set in 2 dimensions. Hard in 3. I could not reproduce this by hand. And it's impossible to draw functions in more than 3 dimensions. This is one of the reasons why, as you progress in your study of econ, you'll tend to move away from graphs and towards equations, because equations are not limited in the number of dimensions, the number of right-hand side variables, and it enables you to analyze more complex systems. Okay, let's start with the original form of the budget constraint, which is, P1 x1 plus P2 x2 equals m. Now, let's solve for x2. Where can I do that? So, P2 x2 equals m minus P1 x1. Now divide through by P2, and we get x2 equals m over P2 minus P1 x1, that's a 1, over P2. Or as the way it's written here, x2 equals P1 x1 over P2 minus m over P2. Now, why do this? The slope is that, negative P1 over P2. That's the slope of the budget line. But look here, if you want to get one more unit of item 1 here, a marginal change, what do you have to give up to get one more x1? Well, you're going to have to give up some x2. Your consumption of item 2 has to change by this quantity, negative P1 over P2, times the change in x1. If you're increasing x1 by 1 unit, then consumption of x2 has to go down by that much. So the slope represents how much of one thing you have to give up to get one more of the other. That's the opportunity cost. So the slope can be interpreted as the opportunity cost. And here it is graphically. If you increase x1 by 1 unit from here to here, then you have to reduce x2 by this amount here. Now, let's look at how the budget constraint can change. First, what happens when income changes? Let's say you get a raise. Now, this is your original budget set. These are all the consumption bundles that are affordable for you, given the two prices, which determines the slope of the budget constraint, and your income. Maybe I should clarify. This line is the budget constraint. This area here is the budget set. The budget set is the set of all possible affordable consumption bundles. The budget constraint is the limit, not in the mathematical sense, of that set. Now, you get a raise. You can still afford all of the old consumption bundles. Everything in the original budget set is still in your budget set. But because you have more money, these choices here in blue are now available to you. Now remember, the slope is the ratio of the two prices. So if you get a raise, but prices don't change, then the slope of the budget constraint has to stay the same. You can still trade off X and Y at the same rate. What happens if your income goes down? Well, again, prices aren't changing. So the slope of the budget constraint stays the same. The budget constraint just moves inward, and you have this smaller budget set. So, increases in income shift the constraint outward, but it remains parallel with the old budget constraint. It enlarges the budget set and improves choice. A reduction in income shifts the constraint inward, still retaining the same slope, and reduces the available options. Now, if your income goes up, you still have all the choices you had before. If you didn't want to change your consumption bundle, you wouldn't have to. So an increase in income can't make you worse off. It just gives you additional choices you didn't have before. It doesn't take away any of the choices you had before. A reduction in income will usually make the consumer worse off. The exception is where you were not spending your entire income before, and you're still not spending it all after an income reduction, so your consumption doesn't change. Now let's look at how the budget set changes when income stays the same, but a price changes. Let's assume the price of commodity one goes down. Since you can define a line by any 2 points, let's take a look at the endpoints again. If you only buy commodity 2, then you are here. If you only buy commodity 1, you are here. Now, the price of commodity 1 goes down. If you're only buying commodity 1, you shift from here to here. The price went down, so you can buy more of commodity 1, which is why it goes in that direction. But where does the other endpoint go? This is the bundle where you're spending all of your income on commodity 2. You're not buying any commodity 1. Well, if you're not buying commodity 1, then a price change in commodity 1 doesn't change anything for you. Your consumption does not change. You stay at the same consumption bundle. So that end of the budget line doesn't move. The slope is the ratio of the prices. So if one of the prices changes, the slope changes. In this case, since a price went down, you now have the same consumption options before in that area, the green, but you also have these in the blue area added that you did not have before. Reducing the price of one commodity will pivot the constraint outward. No old choices are lost, but new choices are added. So reducing a price cannot make the consumer worse off. Similar to with an income reduction, increasing the price, in this case, pivots the constraint inward toward the origin. It reduces the budget set and usually will make the consumer worse off. Again, the exception would be if someone is purchasing 0 of the item with a price change and continues to buy 0, then it does not make the consumer worse off. Taxes. What do taxes do to a budget constraint? An ad valorem tax is a tax that's a percentage of the sales price. It's the most common one is a sales tax. If the tax rate is 5%, then anything that cost $1 before now costs $1.05. 5%, as of today, this is early 2021, 5% is the state sales tax rate across the river here in North Dakota. In Minnesota, it's 6.875. In both states, some localities add local sales tax on top. Clay County adds 0.5%, so the total sales tax rate in Moorhead is currently 3.375%. In Fargo, there is an additional 2% city tax, 0.5% for Cass County, plus the 5% state rate, so the total sales tax there is 7.5%. Now, since an ad valorem tax, if it's applied to everything, raises all prices by the same percentage, the ratio of prices doesn't change. So the slope of the budget constraint stays the same. Here is the budget constraint before the tax was applied, and here is the budget constraint afterwards. It's analogous to an income reduction because some bundles, these here, are no longer affordable with the tax. Now, a uniform ad valorem tax is a very simple case. Here's one that is more complicated. Food stamps. Food stamps are not a tax, they're a subsidy. They're a form of welfare. They're coupons that can be spent just like money, but only on food. Now, here you introduce the concept of a composite good, which we're going to call G. So the budget constraint here is spending on food and spending on everything else. And we view everything else as one good. We usually have more than two goods to choose from, but that can complicate the analysis. Here we're interested in food. So we divide all goods into two groups, food and everything else. Now we know the price of food, we can just specify it, but what is the price of everything else? What does that mean? Think of it as just money. You have to allocate, allocate your resources into two groups, food and money. So the price of not food, the price of G, that's money. Its price of money is $1. So every dollar you want to keep as money costs you $1. And here's the budget set. Without food stamps, your income is 100. Just graphically, the price of food is $1. The price of everything else is $1. So this is your budget constraint. You can have 100 foods or $100, or any linear combination. Now, here it is with food stamps. Notice, the budget constraint is not linear. It has this kink at 40. Now, without food stamps, this is your budget constraint here. Now, if you receive an additional, in addition to your money budget, $40 in food stamps, your income goes up and your budget line shifts outward by $40 to here. If you're spending everything on food, it goes from 100 to 140. But since the additional $40 can only be spent on food, because that's the requirement in food stamps, that means you cannot spend it on anything in the composite good. So your spending on G can't go up. It cannot be higher than there. So this area is truncated. It is not available. And thus, you get this kink at $40 spending on food. Next, numeraire. This is an economic word that just means the thing that you're using as a unit of measure. You have a certain amount of wealth. Now, you can measure that wealth in United States dollars. You can measure it in British pounds. You can measure it in Japanese yen. You can measure it in units of pizzas. It doesn't change how much wealth you have. You're just measuring it using a different unit. Now, if you're dealing with two goods, sometimes it's easier to, instead of measure them in a third unit, dollars, for example, you may want to convert both of them into units of one of them. For example, if we're dealing with pizzas and Cokes, we might want to avoid dealing with dollars and express the budget in units of, well, you can pick either one, let's say Cokes. If you have an income of $100, let's say pizza is commodity 1, Cokes are commodity 2. Then the price of pizzas is 10, and the price of Cokes is 2. That's the environment. Now, this is all in dollars. But you could use Cokes as the numeraire. In that case, your income would be 50 Cokes. The price of pizzas would be 5 Cokes. What would the price of Cokes be? Well, it would be 1. All you're doing is dividing this by that. 100 divided by 2 is 50. 10 divided by 2 is 5. 2 divided by 2 is 1. You now have everything expressed in a numeraire of Cokes. You don't have to deal with dollars. There are certain circumstances where that simplifies the analysis quite a bit. Okay, relative prices. Changing the numeraire doesn't change the budget constraint. It doesn't change the budget set. Because measuring things in different units doesn't make you richer, doesn't make you poorer, doesn't mean you can afford more or less. It doesn't change your wealth. And it doesn't change the ratio of prices. So it doesn't change the slope of the budget line. But in general, this course will focus primarily on straight line budget constraints, but they don't have to be straight. For example, if you get a bulk discount, that is, if you purchase more than a certain quantity, the price goes down. Here's an example of that. The price of commodity 1 changes at a quantity of 20. If you buy fewer than 20, it has one price. If you buy more than 20, the price of X1 goes down. How can you tell it's down? It's because the budget line swings out. And so you get this kink at 20. This is the budget set in that case. Now, if the price goes up at a certain quantity, you're penalized. This is less common in real markets. If you're penalized for buying more than a certain quantity, well, then it would simply kink out at that threshold rather than in. We generally assume this is not the case, but prices can be viewed as negative. If adding something to your consumption bundle increases your wealth, a price could be viewed as negative. This would be, we would not call this a good. In econ, something that purchasing more of it, having more of it, reduces your utility, makes you less happy. That's not a good. We call that, strikingly, a bad. This is the budget line for something with a negative price. In this case, it is X1. And this is the budget set. So if you were to buy, let's say you bought this quantity of X1, well, you could only afford at most that much X2. But if you increased your consumption of X1 to here, now you can afford more of X2. That generally will not be the case in the real world, and usually not what we will be discussing in this course. Okay, thank you for watching, and I will see you next time.